Welcome to Ajka Explainer. Today, we are taking some seriously complex tech and making it, well, incredibly simple. We're talking about a concept that is literally revolutionizing how we interact with artificial intelligence. Think about this for a second. I recently got some blood tests done, right? And when I opened the medical app to check my report, I didn't just get a wall of confusing raw data. No, I got this highly personalized AI-generated summary of my exact blood work, complete with custom FAQs and personal health suggestions. Now, a standard AI like regular ChatGPT or Gemini simply cannot do that. Why? Because they don't have access to my private, real-time medical data. But this app did, and it did it through a brilliant technique called RAG. I know it sounds super complicated, but as we'll see today, it's actually one of the most practical and powerful AI applications out there right now. So, here's our roadmap for today. We're going to start with the problem with a normal AI, then we'll introduce RAG, dive into its big benefits, break down exactly how it works, and finally look at some of the most popular RAG architectures used today. Let's just dive right in. Section 1. The problem with normal AI, and exactly where our standard LLMs are falling short. To really understand why RAG is such a game changer, we first need to understand the flaws of standard large language models, or LLMs. Let's look at a real-world scenario. Imagine you booked a flight, and suddenly it gets delayed. If you go to a standard AI and just ask, "Hey, why is my flight delayed?" it's going to give you a super generic, honestly unhelpful response because it doesn't know who you are. It doesn't know your flight number. But if you ask a context-aware AI chatbot on that specific airline's website, boom, it instantly knows your specific PNR, your exact arrival time, your destination, and the specific weather issue causing your delay. It gives you a highly specific, accurate answer. Standard AI just lacks that personal context. The other major issue with standard AI is the knowledge cutoff date. You see, AI models are essentially frozen in time. They're trained on these massive, sprawling data sets, but that training literally stops on a specific date. So, for example, a model like GPT-5 might have a knowledge cutoff of, let's say, September 30th, 2024. If you ask it about an event that happened in October 2024, it is completely blind to it. It just simply doesn't know.
Section 2. Enter RAG, which we like to call the open book exam.
And this brings us perfectly to the solution. I want you to picture a scenario we've probably all been through. Imagine two students taking an exam tomorrow. Student 1 represents our standard LLMs. They have to read a bunch of books today, memorize absolutely everything, and tomorrow they walk into a closed book exam. They have to rely purely on their memory to answer the questions. Now look at student 2. This student also studies, but tomorrow they get to take an open book exam. During the test, they can actually verify facts, look up real-time information, and double-check their answers against verified texts. I mean, student 2 is obviously going to perform better and make way fewer mistakes, right? Well, student 2 is RAG. So the absolutely crucial point here is that RAG, which stands for Retrieval Augmented Generation, isn't just one single piece of technology. It is a technique. It's a way of giving our AI that open book. Before the AI generates an answer for you, RAG allows it to retrieve highly relevant real-time data from a specific trusted database. It reads that specific info, augments its understanding of the question, and then generates the perfect response. Section 3. The big benefits of RAG and why the enterprise world absolutely loves this. Now that we know what it is, why are businesses so obsessed with this technique? Well, there are 4 massive wins here. First off, it drastically reduces AI hallucinations. You know when AI gets overconfident and just kind of makes things up? By forcing it to look at real data, RAG grounds the AI in actual facts. Second, it keeps knowledge completely up to date, entirely bypassing that annoying knowledge cutoff date we talked about earlier. Third, it is highly cost-effective. Training or fine-tuning an AI model from scratch, that is incredibly expensive. With RAG, you don't have to retrain the AI's brain. You literally just give it a new book to read. And finally, and this is critical for businesses, it maintains data privacy. The AI doesn't swallow your entire company database. It only extracts the tiny specific parts needed to answer a single query. So your sensitive internal data stays completely safe. Section 4. How RAG actually works. Let's look at the actual pipelines behind the magic. All right, let's peel back the curtain a bit. We know it works like an open book exam, but how does the plumbing actually route all this information? Well, it all starts with the ingestion pipeline. Think of this as basically preparing the open book for our student. First, we extract our raw data, stuff like PDFs, Excel files, internal company docs. Second, we obviously can't feed a massive 500-page manual to the AI all at once, so we split the data into smaller, manageable pieces that we call chunks. Third, computers don't understand words. They understand numbers. So we convert these text chunks into what we call vector embeddings. Essentially, these are mathematical representations of the text. And finally, we store these numbers securely in a highly specialized vector database. Now, what's really fascinating here is the difference between a normal database and a vector database. A normal database uses exact keyword search. If you search a medical database for heart attack symptoms, it's only going to fetch documents that have those exact 3 words. But a vector database, it uses semantic search. It actually understands meaning. So if you search heart attack symptoms, the vector database knows that cardiac arrest means the exact same thing, and it will correctly fetch those documents too. It searches by concept, not just by letters. Okay, so once our data is ingested, we move over to the retrieval pipeline. You ask a question. Step 1, your question is also turned into an embedding, a number. Step 2, the system does a vector search, finding the specific chunks of data in the database that mathematically match the meaning of your question. Step 3, it takes your original query, adds the context it just found, and packages the whole thing into one big augmented prompt. And finally, step 4, the LLM reads this augmented prompt and generates a beautifully accurate, context-aware answer for you. Before we move on, there's a quick technical nuance here for the developers tuning in. How you actually cut up your data matters a lot. Your chunking strategy, using libraries like LangChain, can make or break the system. You can use fixed-size chunking, like just cutting the text every 500 words. It's fast, sure, but it might accidentally chop a sentence right in half and completely break the context. Or you can use semantic chunking. Now, this is slower, but it creates high-quality chunks by breaking the text based on actual meaning, ensuring that whole topics stay together nicely.
Section 5. Popular RAG architectures today and how they've evolved across different industries.
So RAG has evolved pretty rapidly. It is definitely not just a one-size-fits-all baseline sidekick anywhere. Let's look at some of the specialized forms being used in the industry right now. We'll start with standard RAG. This is exactly what we just walked through. It uses pure vector search, it has super low complexity, and is highly, highly effective if you're just building straightforward FAQ sections or simple customer support chatbots based on really clean documentation. But then we move to hybrid RAG. Standard RAG is great for understanding meaning, but it's actually pretty bad for exact matches. Like, what if you're searching for a specific employee ID or a really precise serial number? Hybrid RAG gives you the best of both worlds. It combines that semantic vector search with exact keyword search. And as you can imagine, this is massively popular in heavy enterprise environments and e-commerce stores. Then we have RAG with memory. You see, a standard RAG system essentially has amnesia. It forgets everything right after answering your question. If you ask a follow-up question like, hey, can you explain more about it? A standard system has absolutely no idea what it is. RAG with memory fixes this by adding a history layer to maintain a running thread of the conversation. And honestly, that is absolutely crucial for modern, natural-sounding support assistants. Next up is Graph RAG. Imagine you have incredibly complex data where things are highly, heavily interconnected, like dense legal documents or a massive web of financial transactions. Graph RAG uses knowledge graphs, very similar to Neo4j databases if you've heard of those, treating entities as nodes and their relationships as edges. It is a much heavier, more complex system for sure, but it is phenomenal for deep research and things like fraud detection. And this brings us to agentic RAG. Some questions are just too big for one single search. If you ask an AI, explain the 2025 gold price hike and compare it with other metals, it can't really do all of that in one go. Agentic RAG gives the AI autonomy. The AI literally realizes it needs to break your prompt down, it'll search for the gold hike, then do a separate search for other metals, maybe even pull real-time data from an external finance API, and then seamlessly synthesize it all together into one final response. It's incredibly smart. Up to now, we've basically only talked about text, but multimodal RAG? This can process videos, images, and audio right alongside text. The potential here is just massive. Think about the medical industry. An AI could analyze your text-based medical history directly alongside your actual visual X-ray images. Or imagine the applications in complex security and surveillance setups. It's a total game changer. Finally, we have self-reflective RAG. Now, this is the absolute gold standard for research-heavy, strictly regulated industries.
Here, the AI generates a draft response, but instead of showing it to you immediately, it actually critiques its own draft. It analyzes whether the answer is fully accurate and complete, and if it's not, it does another search to improve itself before finally delivering the output to you. And honestly, out in the real world, production systems are often combining several of these architectures to create some truly incredibly powerful tools.
Which leads us to our final thought for today's explainer. As agentic and multimodal RAG systems become completely autonomous, dynamically pulling their own context from across the entire web, from videos, from text, how soon do you think it will be before these systems replace traditional search engines entirely? It's a pretty fascinating future to think about. Let me know your thoughts on this, and hey, if you're interested in actually implementing RAG with Python, drop a comment below. Keep learning, and I'll catch you in the next explainer.